Here we're looking to solve for these problems using the quadratic equation. So here we have 2x squared plus 3x minus 1 equals to 0. It's already in standard form, so we already met step 0. Okay, the a here is the 2, the b here is the 3, and the c here is the negative 1. Next, we plug into the quadratic formula. The quadratic formula is defined there as negative b plus and minus b squared minus 4ac over 2a. So what goes into the first parentheses is a 3, because that is the b term. Then we make the other substitution, so that is 3 squared minus 4 times 2 times negative 1, all over 2 times 2. Okay, so we substitute the b for the b, the c for the c, the a for the a. Next, you want to simplify. Okay, this part you have to put in the calculator. Okay, put this part, not the radical part, just put whatever this is. That's what you're putting into the calculator. All right, and you should use Desmos to multiply those large numbers. That is 17. So it is radical 17 because that 17 was what was inside the radical. Here you can now see this as having two solutions. All right, okay. The first one would be negative 3 plus 17 over 4, and the other one would be minus 3 minus square root of 17 over 4. These are your two solutions here. Okay, you can't simplify that square root 17. All right, let's do the second question. All right, let's put it into standard form. So we have to minus 3 to both sides to make sure it equals to 0. In standard form, it is 3x squared plus 4x minus 3 is equal to 0. The a is 3, the b is 4, and the c is negative 3. The quadratic equation is negative b plus and minus square root b squared minus 4ac all over 2a. So it becomes negative 4 plus and minus square root 4 squared minus 4 times 3 times negative 3 all over 2 times 3. Okay, we can now use Desmos to simplify. It is the stuff on the inside here. We have to plug into the calculator. And when I plug that into the calculator, I notice that it is the square root of 52. Okay, so here we have negative 4 plus and minus the square root of 52 over 6. And let's see, can we simplify the square root of 52? I don't believe so. Okay, so the first factor is, the first solution is negative 4 plus square root 52 over 6. And it's negative 4 minus 52 over 6. Okay, this answer is good for this year, but I want you to let you know that you can actually technically simplify this. Okay, in algebra 2, what you need to do is make sure that these can't break down. So technically this does break down into negative 2 plus and minus radical 52 over 3. The reason, no, it doesn't. Sorry, it doesn't. So I'm incorrect there. You cannot simplify that. And okay, so that is incorrect. So this is bad. The reason why is because all these have to be simplified. So these two would be the correct answer. Okay. All right. All right. Let's do the last one here. It equals to 2x right now, so we have to make it equal to 0. So we subtract 2x to both sides. It does cancel, and you are left with a 4x squared minus 4x minus 15 equals to 0. The a is 4, the b is negative 4, and the c is negative 15. We plug it into the quadratic equation, or the quadratic formula. X is equal to negative 4, okay? Because there's already a negative in front. When you make the substitution, it's still negative 4, because b is negative 4. Plus and minus negative 4 squared minus 4 times negative 15 divided by 2 times 4. Okay, notice that this we have to use a calculator to simplify this. Okay, and then the negative 4 squared minus 4 times negative 15, it is square root 256. Okay, that negative times the negative in the negative times the negative 4 out in front become a positive 4. All right, so square root 52 does simplify. That's why you want to use a calculator. Okay, and that becomes 16. So what I am translating this into is that this was really x was equal to 4 plus and minus 16, because square root of 256 is 16 over 8. Okay, that's your first solution, and that simplifies to 5 over 2. Okay, the second solution is 4 minus 16 over 8, and that simplifies into 3 over 2. So there you go. Those are your two solutions. Okay, notice that this problem, the solutions are rational numbers. So technically you can do the old factoring method here and it works. Okay, all right, there you go.